Wherever brakes and clutches are used in industry, their continued reliable operation is critical. Downtime is usually expensive, and failure of a brake or clutch can mean serious property damage and personal injury. To keep things up and running efficiently and reliably, you must be able to set up and maintain brakes and clutches correctly. And you should be able to spot problems early, before they lead to a breakdown. In this lesson, we'll see how brakes and clutches work. We'll see what kind of maintenance they require, and what conditions can cause them to fail. In addition, we'll show you the kinds of operating conditions that accelerate normal wear, and we'll show you how to keep them in good operating condition. Let's start with what clutches and brakes do. Clutches have an input connected to a driver, usually a motor, and an output connected to whatever is being driven. Most clutches can disconnect the input and output completely at startup, and this lets the motor start up and run without a load. And most can also slip, so the motor can bring the load up to speed gradually. Finally, clutches can connect the input and output firmly, so the motor drives the load at full speed with no slip. In most cases, when a clutch is fully engaged, both the input and the output turn at the same speed. On the other hand, a brake prevents the output from turning. When the brake is released, the input can turn freely. When it slips, there's some drag on the input. And when the brake is fully applied, the input is locked to the output. Nothing turns. Now, some clutches and brakes do not allow slipping. These positive engagement clutches and brakes are either locked up or free, nothing in between, no slipping. This clutch, for example, is either fully engaged or fully disengaged. To engage or disengage it, the input and output must both be stopped, or they must be rotating at the same speed. If not, clashing will wear out the teeth, and the gears may no longer mesh properly, or the wear may cause them to jump out of engagement. Positive engagement brakes are often used to hold a shaft in position while a tool is changed or a machining operation performed. Some positive engagement clutches and brakes engage or disengage automatically, depending on which way things are turning. A ratchet is a simple example of a one-way positive engagement brake. The wheel can turn freely in one direction, but will not go the other way. Sprag or cam clutches do the same thing, but they are smoother and quieter because they have no teeth. Instead, a smooth cylinder, called the inner race, rotates in one direction, inside an outer race. Between the two races are sprags or cams. When the inner race rotates in one direction, the sprags or cams cannot grip the outer race. But when the direction of rotation is reversed, they jam tightly between the two races, connecting them. When used as a brake, one race is fixed. The other race, like a ratchet wheel, will turn freely in one direction, but won't turn at all in the other direction. When used as a clutch, the output can coast, freewheeling or overrunning when the input slows or stops. If you ever have to replace a one-way clutch or brake, make sure the new unit engages or locks up in the same direction as the old one did. Some lock up clockwise, some counterclockwise. Virtually the only maintenance required on a sprag or cam clutch or brake is proper lubrication. Most units are mounted on horizontal shafts and use oil, but sometimes a grease will be required when the unit is mounted vertically. In either case, use the lubricant specified by the manufacturer. Never use a heavy oil or any lubricant rated for extreme pressure service, because it may prevent proper gripping of the sprags or cams. And do not overfill. Too much oil will increase drag. Half full is generally enough, especially when speeds are high. Slower operation can tolerate higher fill levels, but again, follow the manufacturer's instructions. Okay, ratchets, sprag clutches, and other positive engagement clutches and brakes do not allow slip. They are either disengaged or they are locked up. However, most clutches and brakes can slip, and this allows them to start and stop loads smoothly. Frequently, the slip takes place between dry friction facings and a steel surface. The friction facings are usually non-metallic composition linings, although sometimes metals like brass are used. The steel surface may be either a disc, like this, or a drum, like this. Friction allows a clutch to transmit the torque that accelerates and drives the load. And it allows a brake to slow the load down and stop it. Friction depends on three things: One is the area of the surfaces that are in contact with each other. The larger the friction-facing area, the more torque a brake or clutch can transmit. To increase friction, many clutches and brakes may have multiple friction surfaces. Another factor that determines friction is the condition of the contacting surfaces. In most clutches and brakes, these surfaces must remain dry and clean. Moisture or any other contamination can drastically alter the friction and change the performance of the brake or clutch. Friction also depends on the pressure between the friction facings and the steel surfaces. In some clutches and brakes, both the contacting surfaces may move, so the force may have to be applied through a thrust bearing of some kind. Whatever type of bearing is used, it may require maintenance from time to time. Sometimes that will mean lubrication, other times adjustment of components. Be sure to follow the manufacturer's instructions. Now, just because a clutch or a brake is designed to allow slip does not mean it is intended to slip all the time. Most dry friction clutches and brakes are designed for intermittent slip only. Slipping that occurs too often will wear out the clutch or the brake. Slip also produces heat. The longer the period of slip and the greater the pressure while the slip occurs, the greater the heat produced. Now, heat causes lots of problems. Brakes that are overheated may fade, and an overheated clutch may not be able to drive the load without slipping. Clutches and brakes that get hot enough to smoke may be seriously damaged. Overheated friction-facing material on brakes and on clutches can weaken and break up, or it may just wear away rapidly. Very high heat can cause steel drums and discs to warp or crack. Nearby bearing seals may deteriorate. If lubricants leak out into hot parts, smoke and fire is possible. The important thing to remember about slip in friction clutches and brakes is that any more slip than normal will cause excessive wear and heat and early failure. For example, a clutch which fails to disengage fully or a brake that drags will heat up and wear out very quickly. If some parts are warped, bent, or binding, the friction facings and the steel may not be separating completely because the gap between the facings and the steel may be very small. Many units have springs of some kind intended to push the facings apart when the pressure is released. They may be weak or broken, especially if an operator has been riding them or the operating linkage requires adjustment. Sometimes, of course, clutches slip and brakes cannot hold the load because the load is too large. Something in the machinery could be tight, binding, or overloaded. Clutches and brakes may also wear out if they are cycled too frequently. A clutch can start a load and a brake can stop a load only so many times an hour. Cycling it faster than its rating will cause it to overheat because it will not be able to dissipate the heat generated during each cycle. However, even if the duty cycle is normal, a clutch or brake may slip more than normal because of inadequate friction. Lack of friction can be caused by many things, but the most common are inadequate pressure, contamination of the friction facings, or damage to the friction facings. Anything that interferes with full pressure being applied will cause slip. For example, if an operator rides a clutch or brake, it will not be fully engaged. In addition to slip and heat, riding a clutch is also likely to wear out the thrust or throw-out bearing, which disengages the clutch. Sometimes, worn or misadjusted linkages can reduce pressure enough to cause slip. In some units, inadequate pressure can be a result of wear of the friction facings. The condition of the friction surfaces can also cause excessive slip as well as other clutch or brake problems. Contamination can cause some clutches and brakes to grab and chatter or slip. To help prevent contamination during operation, make sure all seals are replaced when necessary. And when installing new clutch or brake facings, work in a clean area. Some wear is unavoidable, but excessive wear can expose the screws or rivets which hold the friction facings in place, and then the steel surfaces can become grooved and damaged. Discs, plates, and drums may all need to be resurfaced or replaced if wear is allowed to become excessive. Finally, contamination may also roughen up the surfaces and lead to wear. To help keep out grit and dirt, make sure all inspection and lubrication covers are in place. Okay, now let's apply this information to the maintenance and troubleshooting of specific friction units that you're likely to find in your plant. But first, let's talk about asbestos, which may still be used in brake and clutch facings. During disassembly and reassembly, make sure you know the procedures for working with asbestos in your facility. Never blow out dust with an air hose, and do not drill, saw, grind, or file friction facings without some way to collect the dust safely. Now let's look at procedures for several types of friction clutches and brakes: the overload or slip clutch, the centrifugal clutch, and electrically operated, pneumatically operated, and hydraulically operated clutches and brakes. Slip clutches are very common and fairly simple. Springs squeeze the friction facings on a steel surface hard enough to prevent slip during normal machine operation. But if the machine is overloaded, the clutch slips. Usually, the only maintenance they need is an occasional readjustment as the friction facings wear down. When this happens, the springs apply less and less pressure, and the clutch may slip before it is overloaded. Centrifugal clutches often use springs to hold the facings away from the drum until the speed of the input shaft reaches its cut-in speed. But as the facings wear thinner, the springs must stretch farther, and the unit may slip. Many friction clutches are electrically operated. Current in an electromagnet produces the force that presses the friction facings and the steel surface together. If the electromagnet is attached to the input or to the output, it must rotate also, and current is usually fed to it through slip rings and brushes. Electrically operated brakes work much the same way, but are usually a little simpler because there is only one rotating part, and the electromagnet can always be stationary. Electric brakes and clutches usually have few problems. If they don't work when voltage is applied, check to see that the armature is free to move, and that the coil is not burned out. If there are slip rings and brushes, make sure they are not sparking, worn, or dirty. If they are, replace them. Electric brakes mounted directly on the motor are very common. Generally, they keep the motor braked whenever power is not applied, so they are released only when power is sent to the motor. Any malfunction which interrupts the electrical supply to the motor also applies the brakes. Springs usually supply the force that keeps the brake supplied as long as the power to the motor is off. When the motor is switched on, a solenoid coil wired into the motor circuit pulls the spring back, releasing the brake. In some units, the release mechanism automatically compensates for wear of the friction facing. Other units, however, may require periodic adjustment. Usually, troubleshooting this kind of unit is easy. Make sure the release linkage is free to move, that the discs are not warped, and that they do not bind in the housing or on the shaft, and that the solenoid and its coil have not burned out. You can use an ohm meter to test resistance or continuity across the coil. If the brake does not stop the load fast enough, compare the friction disc thickness to the manufacturer's specifications. Replace the friction disc if it is too thin. Or the spring may require adjustment. Tightening the spring will apply more pressure, stopping the motor faster. Some of these kinds of brakes have a manual release, but don't rely on it to hold the brake completely off. If the solenoid is not holding the brake fully released, do not run the motor until you find out what the problem is. Clutches and brakes are also operated pneumatically with air and hydraulically with fluid. Some brakes are fail-safe units in which pneumatic or hydraulic pressure prevents the brakes from being applied. If pressure is lost, the brakes lock up. Pneumatic brakes and clutches are typically operated by a piston with seals or by a flexible diaphragm. Compressed air pushes against the diaphragm, which compresses a spring and applies the brakes. Troubleshooting is usually simple. If the unit does not come on or if it slips a lot, the first thing to check is the air pressure or fluid level. Check the friction facings for wear or for damage or for contamination. Check the springs. They may be weak or broken or out of adjustment. Finally, check for air or oil leaks in the piston seals, in the diaphragms, in the unions, and in the hoses. Eventually, if used often enough, every brake or clutch will have to be rebuilt or replaced. Rebuilding them can often be done by ordering replacement parts from a supplier. These parts may be supplied as individual components or as rebuilt kits. When replacing an entire unit, there are three main areas to consider: the configuration of the brake or clutch, the size, and the installation. There are three major ways to mount a brake or clutch: the common C-face mount directly on the motor, a foot mounting, usually between the motor and the gearbox or between the motor and the load, and a shaft mount, in which the shaft is split. The shaft goes straight through the brake or clutch, or part of the unit is mounted directly on the machine. Normally, unless the application is changing, the replacement unit will be the same configuration as the original installation. However, the sizing of the unit may change, usually because of a change in the application or because the old unit wore out too quickly. The first step, of course, will be to check the dimensions of the old unit to make sure whatever new unit is ordered will actually fit. Sometimes special units or adapters may be ordered to fit existing shaft sizes or existing bolt patterns in the mounting. This can significantly reduce the time and the expense of installation. If the unit is electrical, check the required voltage level as well. Typical voltages are 6 volts, 12 volts, 24 volts, and 90 volts. Next, you must determine the size and model number from a particular manufacturer. If the same manufacturer is being used, then the model numbers may match, but if suppliers have changed, you may have to select a substitute. Generally, this will be done based on the horsepower of the system and the shaft speed at the clutch or brake. Most manufacturers provide model selection charts for their products, which can be used for the most common applications. For example, if an application is powered by a 40 horsepower motor operating at 1800 RPM and powered through a 2-to-1 reducer, this manufacturer's selection chart indicates that a Model 315HQ will be required. Notice that most sizes of clutches and brakes can be used in a wide variety of applications. As long as your application falls somewhere close to the middle of the range, the new unit will probably operate well. The exceptions will be if the unit must cycle on and off frequently, if loads are too great, or if temperatures are too high. In general, if the unit must cycle on and off more than 15 times per minute, or if a more cost-effective match between the brake or clutch unit and its application is desired, then a more detailed analysis can be undertaken. This usually involves calculations of actual inertia, torque, power, and heat dissipation over time in order to develop an estimate of the actual life of the brake or clutch in a particular application. After a unit is selected, it must be mounted and aligned. Remember to lock out properly before starting any work at the site. Make sure you know the proper lockout procedure. Make sure you follow it. You should not attempt to install a new unit unless you are thoroughly familiar with the manufacturer's specifications. Most units require precision alignment, and many require careful adjustment in order to make sure that the correct gaps are maintained after the installation is complete. When mating a new brake or clutch with an old installation, be sure to check for shaft runout and wobble. This may occur as a result of worn bearings in the motor or in the driven machine, and may dramatically reduce the life of a brake or clutch. After installation, many brakes and clutches may have to be run in or burnished to make sure the friction faces mate properly and that they can develop full torque. Usually, this will happen quickly under normal operating conditions. In this lesson, we've seen how several different kinds of brakes and clutches work. We've seen what kind of maintenance they usually require. We've seen what conditions can cause them to fail. And we've looked at the major factors to consider when they must be replaced. Though there are many different kinds of clutches and brakes used in industry, the principles for maintaining them, adjusting them, troubleshooting them, and installing them are all pretty much the same. If you understand how they engage and disengage, and how they slip, you'll be able to keep them running efficiently and reliably for extended periods of time. And you'll be able to get the systems that use them up and running again quickly when things do go wrong.